Hi everyone! Last time we talked about this example and notice that we were given P of A given B1 and P of A given B2, and our questions is looking for P of B1 given A and P of B2 given A. Do you realize the A and B, they kind of flip? And this is actually this method is actually how we can calculate the conditional probabilities if A and B are flipped. Okay, so today we're going to generalize this idea and then we're going to talk about Bayes' theorem. So the idea is, first we want to compute P of A, and then we can use the conditional probability. Okay, so in general, we have the rule of probability. If B1, B2, Bn are mutually exclusive events, it means they are pairwise disjoint. Okay, so mutually exclusive means pairwise disjoint. So if we pick any pair, then they are disjoint. Okay, so in terms of picture, this is like that. So B1, B2, Bn, they are disjoint. Okay, of which one must occur? Then P of A, so P of A equals, alright, let me show you. So I also call this theorem, like the potato rule. So you have a potato and then you want to cut it into slices. So what is P of A? P of A, you can see, is P of A and B1, right? The first slice, A and B1. Second slice, A and B2, plus plus A and Bn, right? The potato is cut into n slices, all right? But now, for each of the slices, think about the breakfast rule, the multiplication rule, right? Which one you want to eat, apple and banana, which one you eat first? Okay, so here assume that we know how to calculate P A given B I. So that's why the first one become P of B1 times P of A given B1. And then the second guy becomes P of B2 times P of A given B2, etc. And then the last guy is P of Bn times P of A given Bn. Okay? And we can use the summation notations. Then we don't need to put the dot there. So this is the summation notation. Okay, we have P of Bi times P of A given Bi, where the I goes from 1 to n. So this is the summation notation. Alright, so it really, the picture really like a potato. We cut the potato into slices. Okay, so let's look at example 1. Urns 1, 2, 3, 4, 5. The cave urn has k red balls and 10 minus k green balls. Choose an urn randomly and sample a ball from it. What is the probability of picking a red ball? Okay, let's see. Let's define the event. Let's say A is the event of the ball we pick is red. Okay, and then let Bi be we pick the I've urn. Okay, so we pick the I've urn. All right, let's see. So let me draw some pictures. So we have 5 urns, right? So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 urns. The first urns we have what? 1 red ball and 10 minus k green ball, so 9 green balls. So the second urn we have 2, and it's 3, 4, 5. Okay, and the green balls we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So this is the picture. Okay. So now, how do we solve the problem? So okay. Find the probability of picking a red ball. So we're looking for P of A. So this is like a potato, right? So P of A is then P of A and B1, P of A and B2, P of A and B3, P of A and B4, P of A and B5. And for each of them, we can use the multiplication rule. So we must pick the arm first, then we can sample a ball from it. So P of A given B1. Similarly, P of B2, P of A given B2, P of B3, P of A given B3, P of B4, P of A given B4. And finally, P of B5, P of A given B5. Okay, now let's figure out each of the probability. P of B1. Because we have 5 urns and they are equally likely to be picked. So that's why P of B1 is 1/5. And then P of A given B1. Well, notice that the urn 1, the first urn, has 10 balls, and one of them is red. So the probability of getting red ball from the first urn is 1/10. Okay, the second urn to be picked is also 1/5. But how many red balls are in there? We have 2 red balls, and it has 10 balls in it. And then the third urn, also 1/5, and because we have 3 red balls over total 10 balls, and then here the fourth urn also 1/5, and we have 4 red balls now. The total is also 10 balls, and the fifth one we have 5 red balls. The total is 10. Okay, so notice that here, what do we get? Do you see the denominator is 1/50, and then we have 1 plus 2 plus 3 plus 4 plus 5. Okay, now let's see. 1 plus 2, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. So 15/50. Oh, the common factor is 5. So we cancel 5, we get 3/10. So this is the answer, 3/10. Alright, remark. Okay, remark. Let's see. Okay, so notice that 15/50 is actually the number of red balls over the number of all the balls. Here we have 5 urns, and each of them we have 10 balls, so the total number of balls is 50. And you can see how many red balls are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's why our answer equals the number of red balls over the number of all the balls. Okay, but this, you cannot use this to in general to calculate. Okay, it match in this case because because each ball has the same probability to be picked. Okay, so because each ball has the same probability to be picked. So because each ball is equally likely, so each of them has the probability 1/50. And why this is true? That is really because because each urn is equally likely. Okay, and also because each urn has the same number of balls. For example, if the number of balls in the urns are different, let's say maybe urn 1 has 8 balls, urn 2 has 13 balls, etc., then our calculation will be different. You can see that the denominator is not 10 anymore. It could be 8 or 13. Okay, so that's why in general you cannot just use the total number of red balls over the total number of balls to calculate that. Okay, so that's why so this method is not correct in general. Does not work in general. Okay. All right. Yeah, so it means we still need to do this long way. Okay, the potato, cut it into slices, and then multiplication rule. Which one do first? Okay, so think about that. All right, next, Bayes' theorem. If B1, B2, Bn are mutually exclusive events of which one must occur, then P of Br given A equals this. So we usually use this Bayes' theorem if we know the probability of A given Bi's, but we're looking for the probability of Bi given A's. Okay, so how to show this? All right, so first of all, P of Br given A, we can use the definition of conditional probability. What that is the Br and A over P of A. And the numerator, multiplication rule, right? We can do Br first, and then P of A given Br. And the denominator, we can use the potato rule, right? The rule of total probability. So that is sum I from 1 to n P of Bi times P of A given Bi. Okay, so now that's why we get this formula. And this is the proof. And we mark. So, okay. We mark this theorem is useful when finding P of Br given A is more difficult than finding P of A given Bi. Okay, so if you know some conditional probability, if you want to find the opposites order, then you want to use the Bayes' theorem. Okay, so let's look at some example. Example 2. 4 technicians make repairs when breakdown occur on an automatic production line. Jeanette service 20% of the breakdown, make incomplete repair one time in 20. So 1 time in 20, so 1 over 20. Tom's service is 60% of the breakdown, make incomplete repair 1 time in 10. Georgia services 15% of the breakdown, make incomplete repair 1 in 10. Peter services 5% of the breakdown, make incomplete repair 1 time in 20. For the next problem of the production line is due to an initial repair that was incomplete. Find the probability that this incomplete repair is made by Jeanette. Okay. So let's see. So Jeanette, Tom, and Georgia, Peter, let them. So what is the A? What is the BI? So A is the incomplete repair, right? So A is the incomplete repair. And B1, let's say made by Jeanette. B2 made by Tom. B3 made by Georgia. B4 made by Peter. All right, now let's see. Okay, so we are looking for the incomplete repairs made by Jeanette. So we already know there is an incomplete repair. We're looking for the probability that this incomplete repair is made by Jeanette. So P of B1 given A. So this is what we are looking for, right? Okay, so but the conditional probability, this is P of B1 and A over P of A. Okay, B1 and A, that's P of B1 times P of A given B1. And then P of A, the potato rule, right, is actually P of A and B1. The P of A and B1 is P of B1 times P of A given B1 plus P of A and B2. So P of B2 times P of A given B2 plus P of A and B3. So P of B3 times P of A given B3 plus P of A and B4. So P of B4 times, oh, I ran out of space. Okay, let me move this to the left. Alright, so let me see. Can we move these things as well? Okay, so, alright, so let's see. P of A given B4. Alright, so P of B1. Okay, Jeanette surfaced 20% of the breakdown. So 20% is like 0.2, right? So 0.2 times and incomplete repair is 1 over 20. Okay, P of B1 also 0.2 times 1 over 20. P of B2, Tom surfaced 60% of the breakdown, so 0.6, and the probability of he making incomplete repair is 1 over 10. And then Georgia surfaced 15% of the breakdown, so 0.15. And the probability of she making incomplete repair is 1 over 10. And Peter surfaced 5%. 5% is 0.05. And the probability of making incomplete repair is 1 over 20. Okay, what is this? All right, so let's see. Okay. I would like to simplify this first before I type into the calculator because it has a lot. So let's see. I want to multiply the numerator and denominator by 20. Then the numerator now becomes 0.2. The denominator now becomes 0.2 plus, so this is 10 and 20, they cancel, we get 2. 2 times 0.6 is 1.2. And also here, 2 times 0.15 is 0.3. And plus 0.05. I can put this in my calculator. See, it's much easier. Of course, if you want to put this whole long formula in it, that's fine. Okay, so just up to you. Oops. Plus 1.2 plus 0.3 plus 0.05. Okay, so the answer is 0.1143. We round up. Okay, so usually keep 4 decimal places. Okay, so 1143. So this is the answer. Okay, so now I want you to do more exercise. You can try to find P of B2 given A, P of B3 given A, and P of B4 given A. Okay? Have you finished? Have you finished? Yes. Okay, let's check our work. So, do you notice that P of B1 over A, the numerator is actually this guy, and then P of B2 over A is gonna be the numerator, it's gonna be this guy. So that's why we know it's 0.6 times 1 over 10 over the whole denominator. Okay, so over the whole denominator. And when you multiply by 20, and then the numerator will be, let's see, if we multiply by 20, so it will be 1.2. So exactly, this is 1.2. So 1.2 over, what is this denominator? Okay, 1.2 plus 0.2 is 1.4, plus 0.3, 1.7, 1.75. So 1.75. Okay, and then P of B3 given A, then you will realize it's gonna be, the numerator is gonna be 0.3, the denominator is also 1.75. And then P of B4 given A is gonna be 0.05 over 1.75. Okay, so see, we can actually get the answer so quickly. Alright, so let's see. 1.2, oops, 1.2 divided by 1.75. So 0.6857. Okay, and then next one we have 0.3 over 1.75. 1714. Last guy, 0.05 divided by 1.75 is 0.02857. Okay, so if you have some zeros, I hope you can get like a 4 significant figures. Okay, so this is the answer. Do you have the same answers? Yes? Good. Okay, so this is session 3.7. In the next video, we're gonna do more exercise about chapter 3. See you soon!